CAE modular for LS-Dyna. In this tutorial, we will be looking at capturing rate-dependent stress-strain data and then converting it into LS-Dyna material card MAT24. This search can be performed against the global data center or your individual work group as required. In this case, I will be using my own work group, and I'll be doing this for plastics. And I can start the search. So during this search, the system is finding rate-dependent properties on the database. And 3 materials have been found. I'm going to do this on a Macrolon 7438, which is a polycarbonate. The raw data itself is, as you can see below, and it's got rate-dependent properties, an iron plot, Poisson's ratios, and moduli at different strain rates. I can start the conversion after choosing my output format, and these are some typical LS-Dyna unit systems. So I'm going to do millimeter second ton, and I start the conversion. At this point in time, it's taking the stress strain data and converting it into rate dependent properties. It has computed a modulus for the dataset, and then it has estimated plasticity data up to the point of yield for each of the cases. You can look at this data in more detail by zooming in, and you can see that maybe the modulus curve is a bit too soft for the material, so I want to harden that first. So in order to do that, I'm going to go change the modulus up here. I'm going to make this maybe 2000 megapascal. Maybe. When I click the update model, it'll recompute and stiffen it. So I can check this once again, and it looks a little better. Now you can see that it has started to compute the rate dependency out here. This is at this time producing the material model for LCSR option of LS-Dyna. I can see that the rate dependency is not scaling extremely well. As you can see, there is a gap between the model and the data at the higher strain rates, and I want to tune that a little bit. In order to do that for the LCSR option, I have to work on the stress ratios, and since the model is over predicting the data, I'm going to shrink that by reducing this number out here. This is the stress ratios, and I click the update model, and as you can see, it has dropped that value a bit. Now I want to model the post-yield behavior using my best approximation. I click the select, and I can add data points. This is on the quasi-static curve, trying to keep the data in a net positive slope direction. So I eliminate the lower like that, update model, and now the model has scaled for the rate dependency to all the strain rates. At this point, I have what I would consider to be a reasonable model. I can add any additional information out here that I would need, like a Poisson's ratio, 4 for example, and anything else that are required parameters. At this point, I'm ready to download a material card for LS-Dyna, just like that. And just in case I want to see it, I can view it. And this is what the material card looks like. I can save the material card as well, and when I do the save, the data is then stored as a material card in my material model library, as you can see out there.